Alright, so our question today is, how is tiling a shape's area similar to an array? We've talked about this word tiling. What does that word mean? Tiling. What does that mean? Mason, what does that mean?
It's like times, but it's like 5 by 10.
Okay.
Like that, but it's...
Can you describe what tiling looks like?
Tiling is, well, it is a 5 by 4, like an example, 5, 5, 4, 4.
Not quite. William, what is tiling?
You can see how much space it has.
Okay, by looking at what?
The shape.
Okay, getting closer. Grayson, what's tiling?
Tiling is using a rectangle to fill in a shape.
Do you think you can see tiles when you're tiling?
Yes.
Oh, yes. That's where that word comes from. You have the square or rectangle tiles. I'm going to put tiles in quotation marks because a lot of times they might just be squares on a graph paper. They might be rows and columns, but there's some kind of tile shape. So when we are tiling, we are using those squares to fill in our shape. On a graph paper, it already has those tiles, those squares, ready to go. On regular paper, you might have to draw them in. Yeah, but we don't have our squares. We don't have our, you have to use the columns. Alright, well let's review that word array. Think way back. What is an array? This should be easy peasy review. What is an array? If you don't know what an array is, please look back in your notebook because that's going to be very important. Lily, what's an array?
Array is something where like it's kind of, it's almost, so you make your tile and then you have like your numbers and then you can do like a plus or times to make the array for the equation, and then you can see like the array is like 2 times.
Okay, I like that Lily said an array can use either addition or multiplication. You certainly could just do repeated addition. You could also take that shortcut that we know of multiplication. Aiden, what is an array?
It's something that uses rows and columns.
That's the biggest thing. An array is arranged in rows and columns. An array is arranged in those rows and columns. We did lots of arrays with our counters when we were learning how to make that model. Whatever you mess with in your desk, please stop. So how would these two things be related? How is that similar? How is using tiles to fill in a shape similar to rows and columns? Okay, how are those two things similar? Okay, so both they both arrange, whether it's tiles or counters or whatever we're using, in that row and column format. How else are they similar? Bria, how else are they similar?
Because you can, like, in a array, I think Rose was saying, you can do multiplication or addition. And
we said both use addition, and I'm going to say and, or multiplication. If you wanted to use that shortcut of multiplication, you are more than welcome to. Bria, I'm going to give you a Hershey kiss, and here is why. Not only is Bria listening to me, but if you notice in her language, she said, I think Lily said this. And Lily totally did say this. That means Bria is paying close attention to what her classmates are saying because they have strokes of genius too. So well done, Bria. Great connection. Dorian, how are these two things related?
So, I just looked back in my notebook and I figured out, well, an array has dots coming it inside of the array.
Yep.
Which tile has tiles inside of it are squares.
So our array dots look like our tiles. When you are arranging those dots like we did it when we were making arrays, those look very similar to our tiles. They're slightly different shape, but they kind of take up the same amount of space. Aiden, how are those two things related?
Because just like Dorian, kind of like Dorian said,
Sure.
you can fill in dots. It can do like dots,
Yep.
rows, and columns, but you're just filling it in.
All right, now I'm going to ask you a really thinking question. Since we've kind of established, kind of already said, that our tiles, using tiles to fill in an area, is basically like multiplication. Does that mean everything we know about multiplication I can use with area? What do you think? So I'm going to say this again because I know it's kind of a tricky question. Since we know area, what we've been doing is pretty much multiplication, what we've known about multiplication, does that mean I can use everything I know about multiplication to solve an area problem? I want to know what you think. Gia, what do you think?
Yes.
Why?
Because it's like you can like use arrays and you can use the tiles like to figure it out.
Okay. Asha, what do you think?
I don't think so because for multiplication you can use a number line and for area you can't use a number line.
Okay, so maybe we have different strategies. Good point. Billy, what do you think?
I think yes, because every multiplication equation has an answer, and you would put that in the area, and every shape would have areas, and it has to have the exact amount of square units as much as what the multiplication equation says.
Okay, so we know that both of these are going to solve some kind of problem, so you think yes. Kylie, what do you think?
I think yes because it's just really like multiplication mixed in with geometry because all you're doing is adding up something.
Yeah, there's a reason I taught you how to multiply, and then I taught you about shapes before I taught you this. It's pretty helpful, huh? It's like I thought that through or something. Weird. All right, so we're going to look at one strategy that we've used in multiplication. But before we do that, I want you to draw this shape. You don't have to write that subtitle, but I want you to draw that shape. It's a rectangle, and it says, how can we figure out a shape that is not tiled for us? So you don't have any graph paper, but we do know that this shape is a 7 by 13. Or sorry, by 3. Sorry, 7 by 3. So what strategy could I do to figure out what the area of this shape is because I don't have my tiles? Hunter, what could I do?
On your paper, you could draw 7 lines.
Could I draw in my tiles?
Yeah.
Definitely. I could draw in my 7 rows, or 7 columns, I mean, and my 3 rows. Now, I will tell you that that will work for this, because that's not a very big shape. But if I gave you a 16 by 18 shape, Is that a lot of lines and boxes to draw? Yes. That strategy will totally work. But let's pretend I don't want to draw lines. I do not want to draw my tiles, and I don't have my counters. So what other strategy can I use, Lainey?
You can multiply.
How do you know that?
Because it's going to be the numbers that the boxes would, and how many boxes there would be if there were boxes.
Yes. This is like a fast array.
Yeah.
How is that like a fast array?
Oh. I know.
Yes.
Okay.
Aiden, how is this like a fast array?
Because 3's on the side, and the 7's on the top, and usually the array goes like a upside down F.
Yes. So this is just telling us one row and one column. When we were first learning how to do arrays, Kylie, we were not drawing in all of our boxes. We started doing just fast arrays. And then we figured out we didn't have to do any kind of array. But this is just a fast array. It tells us how many columns and how many rows. What would be my multiplication equation from that array? William?
7 by 3.
A 7, I love that language, by 3. We learned yesterday that in area, this symbol has a different name. We're not talking groups of. I don't have groups of rectangles, I just have one. Thomas, do you remember what it's called?
Oh!
Gio, do you remember? William just used it when he was describing our equation. It's a phi. You should have seen that. How many of you have ever gone with your mom or your dad to like Lowe's Hardware or Home Depot? Have you ever gone to the wood side?
Yeah.
So if you ever look at those,
Oh, yeah.
and you look at the tag, it might say a 7 by 2 by 1. It looks like a giant multiplication equation. What that's saying is that piece of wood, or whatever you're looking at, is 7 feet long,
And
2 feet wide, and 1 foot
Oh.
tall.
Yeah. So it's a 3.
So that would be a 3D shape, right? When you go buy wood, that's 3D. You can hold it. It's not on a piece of paper. So it looks like that, and you're looking at that like, what? What is that? But that is how that math language is used when we're using area. So if you get a trip to Lowe's or Home Depot anytime soon, go just take a look. See all those funny math symbols in there. What is 7 by 3? Yes, Emery.
I can't answer this.
What is a 7 by 3? Use some strategy. Any strategy. Skip count. This is pretty close to a 7 by 2. Mason?
21.
21. Do we know what unit I'm using? What unit I'm using? Data? We don't know. It doesn't tell me feet or inches, so I'm just going to say units. And then because we're doing 2 dimensions, length and width, units squared.
Where?
Or square units.
Why would they use a 2 for feet if there was 30?
Yes. So when you get to 4th grade and you start looking at 3D shapes and how to figure out the area inside a 3D shape, because now you have length, width, and height, you are going to put a 3. Isn't that cool?
Oh, I did.
All right, so let's continue on. So I would like you to write this question. It says, do these rectangles have the same area? I'll write that big on the board so you can see it. That's going to be your subtitle, or if you need to make a new page, that could be your new title. That says, do these rectangles have the same area? So that is our question. So this is a little tricky. We have two rectangles here. We have the 7 by 9, and then we have this 7 by 4 or by 5. Still a 2D shape. Let's not pay attention to this crazy looking one. Let's just focus on the 7 by 9 because we're used to that. How would I figure out that 7 by 9 area of this first rectangle? How would I figure that out? That shouldn't be anything new. Barrett, how would I figure that out? What would be my equation that I'm multiplying? Yep, 7 by 9 or 9 by 7, that works. Ooh, you need to use a strategy. Figure out what 9 times 7 or 7 times 9 is. If you don't know your 9s, you can do a 9s trick maybe, or you can do break apart, or you can skip count. Hunter, what'd you come up with? Yeah. Hayden, what'd you come up with? I'm not on that yet. Lily, what'd you come up with? 63 units squared. Alright. Now let's look at this strange rectangle that I have next to it. All this rectangle has done is been cut. It's been broken. So I have a 7 by 5 right here. Can I figure out the area of that section?
Yeah.
Yeah. What would be my equation to figure out that section? William? 7 by 5. That should be an easy one for you to solve. What is the area of a 7 by 5? Should be an easy one. You can skip count those numbers. Lainey? 35 units squared. And then I have this 4. What do I do with that 4? Is it just 4? Is the area just 4? Ashlyn, what do I do with that 4?
You could do 7 times 4.
How did you figure out 7 times 4?
Because it has this, on the other side, it has the same length.
Yes, think what we know about rectangles. If this side is 7, this side is also 7, and this side is also 7. So I'm going to go ahead and just write another 7 over here. Because we know with a rectangle that those opposite sides are equal. So now I have a 7 by 4. Aiden, what's going to be that equation?
28. Oh, no. 7 by 4.
Go ahead and give me the answer, Aiden.
28.
28 units squared.
28.
Well, now we still have to look at that whole equation, or that whole question. And it said, do these rectangles have the same area? Well, my first rectangle has 63 units squared. And my second rectangle, well, it's still in 2 pieces. So how do I figure out the total area? Because right now, I have one piece of a rectangle. Come on. Why won't you change color? And then I have this other piece of a rectangle. So how do I find the total area? Grayson?
You add 35 plus 28.
35 plus 28. 5 ones plus 8 ones is going to give me how many ones? Aiden, can I swish 13 in the ones column?
Yeah.
What do I need to do?
Put the 1 in the 10th place.
Why?
Because there's not enough room for it.
Because that 1 is a 10. 1 plus 3 is 4. Plus 2 is 6. 6, 10.
Way
Whoa!
faster than 63 plus 63.
So wait a second. Do these two rectangles have the same area? How? How? How do they have the same area? Billy, how do they have the same area?
I was just skipping two.
William, how do they have the same area?
They have the same area line. Just divide it into equal groups.
Well, 5 and 4 are equal. You're on the right path, though. Ashlyn?
Because 5 minus 7 equals 16. And then you would add you would do the 7 by 5, and then you do the 7 by 4, and then you would switch those together, and that would be 63. So they both would have the area of 63. I got it.
Okay. Grayson, what do you think?
So they have a 9 on the top, and on the other one it has a 5 and a 4, and you just have to add up the 5 and the 4 to get a 9.
Oh, so we know they both have this side dimension of 7. And really the only difference is this top one. We have 9, and then we have a 5 and a 4. I'm going to redo this to make it something that you've seen. So instead of a 9 by 7, you might have seen it like this. I basically broke apart my 9 into 5 and 4. And then I did 5 times 7 and 4 times 7. And then I added those two together. Does that look? So again, this is all just break apart. Everything that we just did was just a big version of break apart. Think way back in your brain when we were first learning how to do when we first learned how to make an array, and we made the array on our table, and then we would split it in half to learn how to do break apart and doubles and those kinds of things. That's all we're doing. I'm making 2 mini arrays and then smushing it together to make a big array. Is she not here? Oh, you need to go to Miss Kaisman, sweetie. Kylie, what's up? We have used this word decompose before. What does decompose mean? That prefix D means not, kind of like un that we've been using. So what does decompose mean, William? Yeah, break apart. We did it when we were building shapes in geometry. We're going to break apart this shape. All right, which side would you like to break apart? I have a 6 on the side, and then I have an 8 on top. It doesn't matter to me whichever side you would like to break apart. Grayson, what side do you want to break apart?
6.
You want to break apart the 6. All right. So on your rectangle, cross out your 6, and we're just going to draw a line. Now, obviously that looks like we split it in half. We don't have to break it apart in half exactly, but we could. All right, we're breaking apart my 6. What would you like to break that into? Remember, it has to add to 6. Ashlyn? 3 and 3. That's not what I would have chosen, but if that's what you want to do, we'll go for it. I would have recommended 5 and 1. All right, we're going to continue on. What is my equation to figure out this mini area? What do I do to figure out this mini area? Gia? A little less time playing on our desk and a little more time paying attention would be very helpful. What equation am I going to use to solve that mini area? Lainey, what do you think? Ignore the bottom. Just pretend you're looking at that rectangle. What are our dimensions? What is the length and width of that rectangle in red? It's not a trick question. You just got to read it. 3. What's the length? It's on the board and it should be in your notebook. It's not a 3. Mason?
An 8 by 3.
It is an 8 by 3. It's also written on the board. And it should be written in your notebook. No, not during math. So my equation is going to be a 3 by 8, or 3 times 8. What is 3 times 8? You better have got this written down. William? 24. 24 square units. Well done. Alright, well let's look at our other mini rectangle. Wait, all I have is one number. I just have a 3. Not during math. I just have a 3. So does that mean my area is 3?
No.
So what am I supposed to do? Thomas?
It's the same thing as 8.
Yes. If my top line is 8, then my bottom line is also 8. Because for a rectangle, opposite sides are equal. So now I have 2 dimensions that I can work with. What's going to be my equation to then solve for that? Okay? That's not an equation. Nope.
So for the other box?
Yes, the other rectangle.
So 3 by 8.
So 3 by 8. Well, that's pretty convenient because I've already solved that problem one time. So what is 3 by 8, Aiden?
I have a question. I have the answer and then a question.
Okay, what is 3 by 8 first? 24. So is my total area 24?
No. 24.
No, it is not 24. What is my total area equation? What is my total area equation? Gia?
34 plus 24.
Yes. I need to look at the whole thing. So my first mini section was 24. My other mini section was 24. I'm going to add those mini areas together to give me a total area. Gia, what is my total area?
48.
48 units squared, or square units. Okay?